So for FRQ number 2, it asks us to draw the free body diagram of the block and label all the forces that act on the block as it slides up the plane. So I'm going to draw this inclined plane right here. The block M, there's theta right there. FG acts down here. We have an FGY. And there's our FGX right there. We also have an FK. We also have an FN. And then we also have a force. Block like that. The force can be split up into components. I'm gonna call it Fy and then Fx, and then theta's right there. Okay. Next, part B. It asks us to develop an expression in terms of m, theta, f, mu, and g for the block's acceleration of the plane. So I'm just gonna look at all the forces that act in respect with when thinking about the incline as the x-axis. It's going to be your fx pushing it upwards, up the incline, and you're going to be your fgx pulling it down, and then your fk opposing your force, opposing your motion, because ma. We see that fx is going to be f cosine theta. Some trig right there. Your fgx, as we know, should be mg sine theta. Your fk is going to be mu fn. However, your fn is special in this case. It's not just fgy, but also fgy in combination with fy, because they're pushing in the same direction, so fn has to equal the combination of fy and fgy. So that's going to be equal to mu fgy plus fy. That's going to be equal to mu. We know that fgy is mg cosine theta. And then using trig, we know that fy is going to be f sine theta. Like that. So what I'm going to do is just going to plug in all these, substitute all of these in. So it's going to be f cosine theta minus mg sine theta minus mu mg cosine theta plus f sine theta equals ma. I'm going to simplify it out, expand it out, make it cleaner. F cosine theta minus mg sine theta distributes at mu, so it's mu mg cosine theta minus mu f sine theta equals ma. I see that these two terms have f, so I'm going to factor it out, making f cosine theta minus mu sine theta. That I see that these two have mg, so take that negative mg's out. It's gonna be sine theta plus mu cosine theta equals ma. So your equation is gonna be f and then parentheses cosine theta minus mu sine theta minus mg sine theta plus mu cosine theta equals your a when you divide by m. That's your formula. Like that. Next, we have part C. It says develop an expression for the magnitude of force F that will allow the block to slide up the plane with constant velocity. So when we read constant velocity, we know that A equals 0. It also asks us to find the relationship between theta and mu. So what I'm going to do first is F equals ma. So it's going to be fx minus fgx minus fk equals 0. I'm going to isolate the f, so it's f cosine theta. Add over the fgx and fk. So mg sine theta when you add over the fgx plus mu mg cosine theta plus f sine theta. Like that. what I'm gonna do now is expand it out. So it's mg sine theta plus mu mg cosine theta plus mu f sine theta, like that. And then next, I'm gonna divide by cosine to isolate for f. When you divide by cosine with this, you can get mg tangent theta, like that. Because sine divided by cosine is tangent. When I divide by cosine with this, I'm just gonna end up with a mu mg, that. And then when I divide cosine, let's see. When I divide cosine over here, it's gonna be mu f tangent theta, like that. I have an f, a term with f over here and a term with f over there. I'm gonna be f minus mu f tangent theta equals mg tangent theta plus mu mg. Factor out the f's, that's gonna leave me with f equals 1 minus mu tangent theta, like that, equals, factor out the mg's, it's gonna leave us with tangent theta plus mu, and then f equals, dividing all of that, dividing this right here. That's your formula for f. Now it asks us to find the relationship between theta and mu for it to be physically meaningful. So it gives us a condition that the block is sliding up the plane, which means that the force has to be positive. So if the force has to be positive, we need to make sure that both the numerator and the denominator stays positive. So for the numerator, we know that mg is a constant. So what we're caring about right here is the tangent theta and then the mu. So we need to make sure the tangent theta plus mu is positive. So tangent theta plus mu is greater than 0. So what I can see from here is we need to know that tangent theta is just greater than mu. That's one of the relationships, right? Next, we look at the denominator. We need to ensure that this right here, this whole denominator is greater than 0. So it's 1 minus mu tangent theta. It's greater than 0, leading us to be 1 is greater than mu tangent theta, like that. So I just divided mu over, so it's gonna be 1 over mu is greater than tangent theta. And then that's our second relationship. Those are two relationships to ensure that f is positive, meaning that the block will be sliding upward, up on the incline. Thank you.